Have you ever watched a factory robot or even just a traffic light and wondered, how does it make decisions so fast, faster than we can even blink? Well, it's all thanks to this invisible, lightning-fast process that is, and I'm not exaggerating, the true heartbeat of all modern automation. So let's dive right in and see how it works. So really, how does a machine think that quickly? How can it possibly see what's happening, process it, and then react all in a fraction of a second? You might think it's watching everything all at once in real time, but the actual answer is, well, it's a lot simpler and honestly, way more brilliant than that. The whole secret is this little thing called the PLC Scan Cycle. You can think of it like a simple three-step dance that every single programmable logic controller, or PLC, does hundreds of times every second. And right now, we're going to break down that dance step by step. Okay, so it all kicks off with step one. Before a PLC can do any thinking, it has to listen. It has to look at the world around it. This is the moment it gathers all its information. Is that button being pressed? Is that sensor tripped? Is that switch on or off? But here is where it gets really clever. The PLC doesn't try to watch everything live. Instead, for just an instant, it freezes time. It takes a snapshot of every single input, all at the exact same moment, and stores that picture in a special part of its memory called the input image table. This gives it a totally stable, frozen-in-time picture of the world to work from. And this is the core idea right here. For that tiny fraction of a second while it's thinking, this picture is reality for the PLC. It doesn't care if a button gets pressed a microsecond after the snapshot was taken. For now, all that matters is what's in that picture. All right. On to step two. The PLC has its picture. Now it's time to think. This is the execute program step. This is where it actually runs the logic, the instructions that a person programmed into it to make its decisions. And here's the crucial part. During this step, the PLC is completely ignoring the live physical inputs. It is looking only at that snapshot it saved in its memory. It just goes through the program, line by line, rung by rung, and compares the instructions against the input states from that picture it took. So check this out. Based on its snapshot, the PLC sees input 1 is on. The program says if input 1 is on, then get output 5 ready. So it does. Then it sees input 2 is off, so it does nothing. Then input 3 is on, so it preps output 6. But notice the keyword here is prepare. It's not actually doing anything yet. It's just making a list of decisions. And that brings us to the final step in the dance, taking action. After all the thinking is done, the PLC has to actually send its decisions out to the real world, to turn on the motors, light up the lights, and open the valves. This is the update outputs phase. And just like it did with the inputs, it uses a kind of holding area for the outputs. All those decisions it just made, they get written to another special memory location called the output image table. It basically figures out the entire game plan first, which outputs turn on, which turn off, and gets it all lined up and ready to go. And this is such a critical detail. The outputs don't just switch on one by one while the program is running. No way. The PLC finishes its entire program, finalizes the plan in the output image table, and then, in one single blast, it updates all the physical outputs at the exact same time. This is what makes the PLC's actions so consistent and so predictable. So, okay, we've got this three-step process. Read, execute, update. It's a neat little loop, but why does this structure matter so much? Well, it all comes down to one thing, just unbelievable speed. See, this isn't something that happens just once. The very instant the PLC updates its outputs, it starts the whole cycle over again. It takes a new snapshot of the inputs, reruns the program, and updates the outputs again. It is a relentless loop that just happens over and over and over. So how fast are we talking? Well, a pretty typical scan time for a PLC is around 10 milliseconds. That is 1/100th of a second. To put that in perspective, this entire process, seeing the world, thinking and acting, can happen 100 times every single second. It's just staggering. And that really says it all, doesn't it? This incredible speed is what creates the illusion that the machine is reacting instantly. It's not magic, not at all. It's just this incredibly fast and relentlessly repetitive cycle that makes automation feel so alive. All right, so let's tie all this together. What do you really need to remember? The scan cycle is a constant three-step loop. Read, execute, update. It works off a snapshot of the inputs, which is key for consistency. It all happens in just a few milliseconds. And it's that insane speed that allows a PLC to respond almost instantly to whatever's happening in the real world. So, I'll leave you with this final thought. If this super fast, steady cycle is the very heartbeat of automation, keeping everything in perfect rhythm, what do you think happens to a huge, complex system when that heartbeat starts to slow down? Or even worse, what if it skips a beat? Something to think about.